Okay, guys, this video is the solution to the second quiz you took, reviewing for the AP test. We'll look at each of these sections one at a time. For part A, how much grain arrives at the facility? I'm assuming that you've read the question since you've done this already. The rate that I have the red arrow pointing at is the rate at which grain arrives. Grain is arriving from 0 to 9 hours during the workday. So we just put that in Math 9. We have to include the units. And so it's 389.373 cubic meters. For part B, they want to know the total amount of grain at the end of the workday. Now, this is a little different than maybe one that we looked at earlier because we have different times. If you notice, it says here that we only process from hour 1 to hour 9, but grain arrives from 0 to 9. So that's why we have different limits here. It's the integral from 0 to 9 for the amount of grain entering, but you'll notice here 1 to 9 for the amount leaving. When you do that, you get 215.545 cubic meters. For part C, what is the amount of grain increasing or decreasing? Well, if you think of finding the rate of change, well, the rate of change of the amount is the derivative of that, or the amount entering and the amount leaving. So we just use E of 4 and L of 4. So in my calculator, E of 4 is 38.462. L of 4 is 43.134. So we can say since the rate of grain is leaving, the rate of grain leaving is larger than the amount of grain arriving, then the amount of grain at the plant is decreasing. You have to write out a sentence there. Okay, you don't have to write a paragraph, but you have to write it out in a sentence, and you actually have to have this in this box. You have to have those numbers to justify. That's why it says show your work and justify your answer. That box justifies your answer because you've demonstrated that you've calculated E of 4 and L of 4. On the back here for part D, find E prime of 6. So you just use Math 8 in your calculator to get E prime of 6, and it's negative 2.520 meters cubed per hour squared, right? Remember when we take a derivative, kind of like velocity would be meters per second and acceleration would be meters per second squared. It's the time element that is being squared there. So it's kind of a strange unit, which is why they want the units there. What does this mean? This means the rate at which grain is arriving at the plant is decreasing by 2.520 meters cubed per hour squared. In other words, the acceleration is decreasing, but you have to use that in the context of the problem. Saying acceleration is not going to qualify because it's not a problem of some particle motion problem. It's the amount of grain arriving. So you would say the amount of grain, the rate at which grain is arriving, not the amount of grain, but the rate at which grain is arriving is decreasing. Finally, probably the toughest part of this was part E here. Write a function, A of t, to represent the total amount of grain. You actually already did that in part B, so you kind of already have that there. And here's a problem that occurred for quite a few of you guys on the first quiz where you were not testing endpoints. You have to test the endpoints, okay? So a max does occur at critical numbers, but it also could occur at the beginning or the end. So you have to show, in order to justify your answer, you have to show that you tested the endpoints. So we're going to test 0 and 9. Well, there's a possibility of some critical numbers. So what I do is I took the derivative here. You'll notice here I've taken the derivative. And A prime of t, well, the derivative of 200 is 0. The derivative of that middle integral is just E of t. And the derivative of the second one would just be L of t. And actually, I've got a small mistake there. This should not be 9 here. That should be a t. So I apologize for that. So now that we did that, we graphed that, put that in our graphing calculator. If you've put the first function in as y1 and the second function in as y2, you just say y1 minus y2. See where that crosses the x-axis, and it crosses at 3.8048. So I've got to test that number as well for a time. This is when you would exit, store that under alpha A or alpha B, some letter that you choose. And so now I have to test all three of these values. That's where this chart here is important. This chart right here. So I've got this chart, and I'm going to test my three time intervals, 0, 9, and 3.8048. Obviously, when we started, we had 200. They gave us that in the problem. What happened at the end of the workday, or hour 9, we already solved for part B, so we already have that answer, 215.545 from part B. But how do we solve for the other time element? Well, the other time we have to put into our amount function that we wrote at the beginning here, and when we do that, you'll get 411.141 cubic meters. So the maximum amount occurs at hour 3.8048, but the maximum amount at any one time on the facility is 411.141. Hope that helps, guys. Have a great day.